Hi everyone, my name is Karen and welcome to my video presentation, the Global Airport Atlas. So this project visualizes 7,698 airports and over 67,000 flight routes from the open flights dataset. My goal is to build a visualization that not only explores where airports are located, but also how they connect with each other. So let's begin with the overview tab here. On the left, we can see the altitude distribution histogram, which gives an overview of how airports are concentrated most airports are concentrated below 1,500 meters. On the right, we have the top countries by airport count, which reveal the major aviation hubs such as the United States, Canada, and Australia. This altitude versus latitude sampled scatter plot use the x-axis for latitude and y-axis for altitude. The points are color encoded by country, which aligns with Bertin's hue for categoricals. So this plot is sample of up to 2,000 points to reduce overplotting and cognitive load on the user. So what we can see from this chart is that most airports cluster at low to moderate altitudes across a wide latitude range, with clear high altitude outliers such as Ecuador and Bolivia. Now, next explore the clustering tab. So this clustering module groups airports by geographic proximity using k-means. So here, users can interactively adjust the number of clusters from 3 to 15. And this altitude by cluster box plot reveals the geographical elevation differences between regions. For example, in mountain zones versus lowland hubs. In this geographical clusters chart, each point is an airport positioned by its coordinates and colored by its ID, cluster ID. So the continuous blue scale represents 5 clusters, moving from lighter to darker tones. So notice how this map naturally segments into regional clusters. For example, lighter tones in the Pacific and Australia, mid blue tones across Europe and Africa, and darker tones spanning Asia and America. So this design applies the Gestot's principle of proximity and similarity, where airports that are geographically close and share similar positions on the map are perceived as belonging to the same group. By encoding cluster membership with color value rather than hue, the visual maintains perceptual uniformity and avoids categorical cluster. Below, the per country cluster composition bar chart shows how these clusters distribute within nation. So the x-axis lists the countries and the y-axis counts the number of airports. And the same color scale connects back to the map above. So from here, we can see patterns such as the United States dominating one cluster, while smaller nations show narrower distributions. And this reflects the uneven geography of global aviation infrastructure. So this complementary view links spatial grouping to national contribution and helps the audience to interpret not just where classes exist, but which regions drive them. Next, let's explore the statistical analysis tab. So the correlation matrix here visualizes how features such as altitude, latitude, and longitude relate to each other using color intensity to show strength and direction. Here, the 3D PCA scatter plot, powered by Plotly, visualizes patterns by country in reduced dimensions and shows which airports feature similar features. In the final tab, network analysis focuses on connectivity. So in Network X, I constructed a directed graph where airports are the nodes and the routes are the edges. So this dashboard calculates the key metrics like network density and degree centrality and identify the world's top hubs. So this interactive network visualization displays the top 30 airports with node size and color representing importance. And when you hover your cursor, you can see the airport names and centrality values. For example, Frankfurt Airport. For example, light-colored nodes such as Frankfurt Airport, Amsterdam Airport, and CDG emerge as dominant nodes. So this graph illustrates how air connectivity relies on a few high-degree nodes, showing the small world nature of aviation networks. So in summary, the Global Airport Atlas demonstrates how thoughtful visual and computational design can reveal a lot of hidden geometry of global connectivity and turn raw data into a compelling visual story. Thank you for watching.